look at Cimphony's single line diagram editor and how we can use that to create sim data. What we have here is Cimphony with a blank workspace, no projects, no resources, and we will start from scratch to create some sim data using the single line diagram editor. We start off by right clicking, selecting new and saying we want a new Cimphony project. We will call this project example and put it in the default location within our workspace. This creates a blank project with two folders, incremental and network. You can create any number of folders here. These are just two that are created as standard. We'll now tell it we want to create a new Cimphony resource. This will create a new blank file in a sim_rdf XML format. We will call this test-network.xml. What we have now done is created our test network, loaded it into our browser here, and we can see it's blank. At this point we could decide to add some sim objects that we know we want. We click the plus icon and now we select the meta model that we want. Here we can see the meta models that exist within Cimphony, and we will select Sim15, which is the most recent version installed. Here we can start to type in what we're looking for, in this case geographical region, with it auto-completing based on the search string. We've now added our blank geographical region in, and if we select the instance we can give it a name. We will call it Scotland. At this point, if we select save, it will write it to the workspace, and we can see here that our test-network.xml has 336 bytes. If we open it within the text editor, we can view the raw sim_rdf XML. But we don't want to edit the RDF XML, and we don't want to add everything here as objects. If we click the single line diagram button at the top here, we can choose which resource we want, which is our only one loaded, or test network. We click through, we want to create a new diagram, and we can select our source schema, in this case Sim15. We can select the transform that we want, in this case we want the operational one. Planning here would create topological nodes, whereas our operational will create connectivity nodes and bus bar sections when we define a bus. There's only one inverse transform for Sim15 to the single line diagram. We click finish, and what we have now is we have our single line diagram editor opened, and we still have our browser window opened here. We can choose to shrink the browser window slightly if we wish to reorganize it. Here, if we click the arrow, we can load our palette, and here we see all of the components currently within the single line diagram editor. If we begin, we can simply add a generator in by clicking on the diagram. We can give it a name, call it Gen A. At this point, the generator exists only within the single line diagram editor window. It has not been translated across to our test network. By clicking save, we now populate the sim objects that correspond to our generator. We have a synchronous machine, a generating unit, and we have the diagram with the diagram objects that are now created. If we remove the empty associations and the empty attributes, we can shrink down what we're viewing here. So we can see our diagram contains a single diagram element, and the linkage here is to the synchronous machine. We can start to add more elements here. We can create a bus, and we can join up our generator to our bus. Now if we click save, we've created a bus bar section and a connectivity node as well. If we look at the bus bar section, we can follow how the sim represents this. There's a single terminal going to our connectivity node, and our connectivity node now has two terminals. The first is to our bus bar section, the second is to our synchronous machine. The terminal itself has a diagram object here with 2 points to represent the line that's drawn on the diagram. We can continue to edit in here. We can add in our two-winding transformer. We can add another bus, and we can join these all together. Once again, if we click save, we will populate all our new objects. We have our power transformer with power transformer ends, and we have all of our terminals. There's now two bus bar sections. We can continue along this route, saving within the test network. At this point, we've not actually written the test network XML file, we've simply populated the objects. Clicking save will once again write this to the workspace. We're currently in the single line diagram editing perspective. We can move to the Cimphony perspective, which moves us back down our outline, our project explorer and our resources. We can now see the size of our test network XML has grown to 10 kilobytes. Once again, if we load this into our text editor, expand this view out, we can see the raw SimRDF XML that has been created to represent this. Here we have a split editor with the two loaded together. We could, for simplicity, drag this into the window to shrink them, put them back together. If we go back to our single line diagram editing mode, we can drag it over to the right again to split the window. There are a number of components here, each mapping to different sim classes. Alternatively, we could create our instance here and say we wish to have a conforming load. We may wish to do this because by default the load in our single line diagram editor will map to a energy consumer, the abstract class conforming load inherits from. So we now have our conforming load. We can actually select our conforming load and drag it onto the diagram, and it creates the corresponding entity. We can join up our conforming load with the bus, and if we save here, we can now see our conforming load has a terminal, and the terminal has joined to the connectivity node that has 4 terminals for the power transformer, generator, load, and the bus bar itself. This has been a brief overview of how the single line diagram editor works within Cimphony and how we can use it together with the browser to create sim data from scratch.